Okay, so in this video we're going to have a look at some difficult direct and inverse proportion questions. Now we're going to have a look at a little variety of questions, starting with some slightly easier ones and building up to this kind of question that you can see on the screen. But throughout this video I'm going to assume quite a lot of knowledge in regards to your direct and inverse proportion, so do make sure that you check out the full videos on those in the description before you check this one out if this is your first time looking at this topic. But with that being said, let's get started. Okay, so starting with one of the easier questions here, and I think this one is only easy because this is a calculator-based question, so we can use a calculator for this. Now I would suggest with all these questions, given that you already have a little bit of knowledge on direct and inverse proportion, which is who this video is aimed at, I would suggest that you have a go at each of these questions and then obviously go over the answers with me. So do that and pause the video at the start of each question, but otherwise we're just going to go through these question by question. So starting with this first one. Now it's talking about inverse proportion. So it says y is inversely proportional to the square of x. So straight away we're going to write down our formula, which is y is equal to k over x squared, the square of x. Okay, so there's our formula. It says when y is 8, x is equal to 2.5. So this one's okay, we've got y is 8, so 8 equals k over, and we've got 2.5 squared. Now I would prefer to see this question as a non-calculator question really, but in terms of our order of difficulty, considering this is allowing us to use a calculator for this question, this is going to be our easiest one on here, and you're going to see on the next one we're going to have a question similar to this, but it's going to be non-calculator based. So for this one here, we've just got to work that out. So on the calculator, 2.5 squared, which is 6.25. So we can multiply both sides here by 6.25, and that's going to allow us to find our value of k, or just in terms of our working out, we're going to multiply by 2.5 squared. There we go, so multiply by 2.5 squared, and we get our value of k. So 8 times 2.5 squared, which again, as we've said, is 6.25, gives us the answer 50. So k is equal to 50. There we go, so k equals 50. Now that's the first step. Obviously in all of our next steps now we need to actually write our formula. So we'll put that back into the original equation that we wrote. So y is equal to 50 divided by x squared. And it says here, and this is the only reason why this is a relatively tricky one, is it says find the negative value of x when y is equal to 8 over 9. And it's worth highlighting that negative value element there just so we don't forget that. Now, okay, let's put 8 over 9 into our little equation here. So we have 8 over 9, which is equal to 50 divided by x squared. And there's a few different ways that we could look at this. The best way that we can do this now is to rearrange it. And if we rearrange this, so first of all, let's times both sides by x squared, and we would end up with 8 over 9 x squared, or 8/9 x squared, is equal to 50. And then we can divide both sides by this 8 over 9. Obviously, if we didn't have a calculator, we could times by the reciprocal there, we could times by 9 over 8, but as we do have a calculator, we can just type in divide by 8/9 both sides, and divide by 8 over 9. So let's do that on the calculator, divide by, press your fraction button, 8 over 9, and you get the answer 225 over 4. So after that step there, we get x squared is equal to 225 over 4. And obviously we need to square root that. Now again, because this is non-calculator, you can do that, because this is on a calculator, it's easy enough just to type that into a calculator. And if we do the square root of that, we get the answer x is equal to 15 over 2. And that was nice and easy, just doing it on the calculator. It's worth discussing how we would go about this non-calculator, but as it is a calculator question, we'll stick with it for the moment. Now it says in the question, don't forget, find the negative value. And this obviously comes back to just the basic concept that if I ask you what the square root of 25 is, you can give me the answer 5 or -5. So obviously on a calculator, if you type in the square root of 25, it's only going to give you that positive version. It defaults to the positive number. So in this particular example here, where we've got 15 over 2, our answer is just the negative version of that. So it is -15 over 2. And there is our final answer. So there we go, that's that one. Now again, In order for this to be really one of the more difficult ones, I'd prefer to see that non-calculator. So just doing little elements like timesing 8 by 6.25 without a calculator to get the 50, and obviously thinking about this step here where we divided by 8 over 9, and how if we didn't have a calculator we'd have had to have times by 9 over 8, the 50 anyway. And that would have given us that fraction there, and then we would have just found the square root of 225, which is 15, and the square root of 4, which is 2. So we could have done that without a calculator, and that would have made it a lot trickier. But there we go, there's our first question, a nice one hopefully to get started into this set of questions. Let's have a look at our next one. Okay, so on to our next question, and as I said, this is going to be a non-calculator version. Now it is a little bit different, we've got direct proportion, and we've got some different formulas and numbers, but we're going to do this one without a calculator. So it says here y is directly proportional to the cube root of x. So straight away, before we even read on, we can write y equals k lots of, and then the cube root of x. And then straight away we can start reading our next line. So we've got when y is 1 1/6, when x equals 8. So we can plug those numbers in. So first things first, I would rather not put 1 1/6 in, especially considering that I'm not using a calculator. I would much rather turn that into an improper fraction and then obviously use that. So I'm going to write that as an improper fraction, which is easy enough. So 1 times 6 is 6, add the 1, which is 7 over 6. So I'll put that in place of y. So 7 over 6 is equal to k lots of the cube root of x, so the cube root of 8. Now we know that the cube root of 8 is 2, so let's write that over here. The cube root of 8 equals 2, and actually we can just get rid of that then and put 2 in its place. So let's get rid of that and put 2. K2. Now obviously when we're looking at using algebra, we prefer to put those numbers, or we're going to always put those numbers in front of the letter. So rather than writing K2, let's write 2K. So let's get rid of that again and put 2K. And there we go. So 7 over 6 is equal to 2K. Okay, so as I said, the reason that we've written there 1 1/6 as an improper fraction is for this next step now. So what we're now able to do is apply normal fraction rules. So we've got to divide both sides by 2 to get our value of k. And because we've got 7 over 6 there, we can just apply those normal fraction rules. So we need to do 7 over 6 divided by 2. And to keep it as a fraction, I'm going to write 2 as 2 over 1. So there we go. And that's going to isolate k and mean we can find that value. And obviously just normal fraction rules here, so we'll flip over that 2 over 1 and make it 1 over 2. So we've got 7 over 6 times 1 over 2, which equals 7 times 1 on the top, which is 7, and 2 times 6, which is 12 on the bottom. So 7 over 12 is equal to k. There we go, so our non-calculator methods here. Obviously that'd be nice and easy if we had a calculator, because we'd just type in 7 over 6 divided by 2. But there we go. Moving on to our next step then. Now we've got our value of k. We just need to put that back into our formula. So our formula is y equals k lots of, and now we know that k is 7 over 12, we can put that in. So y is 7/12, and then the cube root of x. And there we go, there's the formula that we're going to use. Now it says here, find the value of y when x is 64. So this is actually a relatively nice one in the sense that we are not going to have to rearrange this, because when we put that x equals 64 into this formula, it's going to straight away give us our answer. Again, though we don't have a calculator, so we do need to do it without a calculator, but we're going to get our answer straight away. So we get y is equal to 7 over 12 multiplied by the cube root of x. So let's do this working out here. The cube root of 64, which hopefully you know is 4. 4 times 4 times 4. So we've got 7 over 12 times 4. And there we go. Again, we can just treat that like normal fractions. 4 could be written as 4 over 1. And if we times the top there, 7 times 4 is 28. And 1 times 12 is 12. So we get a final answer there of 28 over 12. Now, again, it is a fraction there. We should be applying our best practice and simplifying that down. The top and bottom both divide by 4. So that'd be 7 on the top and it'd be 3 on the bottom. So there we go, obviously always applying that best practice of simplifying your fractions. So our answer there is 7 over 3, although we could be okay there writing out the answer as 28 over 12 as it hasn't asked for our final answer to be simplified. Again, we could even convert it into a mixed number. We could write it as 2 1/3, but there we go, there is our final answer, 7 over 3. Okay, so we're going to step it up a little bit now. We're going to look at sort of combining some of these together. So let's have a look at our next question. Okay, so on to our next question. Now you notice there's a bit of a jump up in difficulty in this one, and you might have already seen just by looking at those first few lines that we've got direct and inverse proportion in the same question. So it says here h is inversely proportional to p in our first line. And then in our second line here it says p is then directly proportional to the square root of t. Now on the next line it says, given that h is 10 and t is 144, when p is 6, find a formula for h in terms of t. And we'll deal with that last line when we get there. Now if we see these words, inversely proportional to and directly proportional to, we'll have to deal with those separately and find the equation or the formula that we're going to write for those two. So if we start going for it, we'll write our formula for h, which is inversely proportional to p. So look at that first one then. We're going to have h is equal to k over p, and again we're going to find our value of k by picking out these values from down here. So it says h is 10 and p is 6, and there are two that we've got that are related to this first formula. So if we sub those values in, we've got h is 10, so 10 is equal to k over p, which is 6, and there we go. So if we times both sides by 6, and I'll write this working out in, so times by 6, and we get k is equal to 60. And then again we can write our formula for that, so plug in that piece into our formula, and let's bring that down the bottom. We've now got that h is equal to 60 over p. And there's our first one dealt with. Now let's have a look at the next one. So we've got p is directly proportional to the square root of t. This is direct proportion, so we'll write p is equal to k root t, our direct proportion formula. And again, let's find the values and put those in. So in this one here, we've got p and we've got t. So t is 144 when p equals 6. So let's put those pieces in. So 6 equals k multiplied by the square root of t. Now again, let's write the working out down. The square root of 144 is 12. So we go k times 12, or 12k. So let's write that in the correct order. K equals 12. Sorry, 6 equals 12k. There we go. Now, dividing both sides by 12. So here we go, let's divide both sides by 12. So we've got the value of 1k. Let's just write that in again. There we go. And we get k equals 6 over 12, which simplifies down to 1/2. There we go. Now, again, didn't mention this at the start, but this is a non-calculator question. So we do need to just think about simplifying that there without a calculator, which is easy enough to do. But there we go, let's plug that half into our formula. So we've got p equals 1/2 root t. And there we go, there's our two formulas. Now we can look at this last line. Now it says here, find a formula for h in terms of t, which means we want it to say h equals, and the only letter we're allowed it to be in that after the equals part is t's, and that would be in terms of t. So we've got our formula here, which is p equals 1/2 root t, and p is also on the bottom of this little formula here. So what we're going to do is we're just going to replace the p with what p is equal to, and p is equal to 1/2 root t. So let's put that in there. So we've got h equals 60 over 1/2, and just about put that in, root t. There we go. Now, technically, that is a formula for h in terms of t, although we are breaking some rules here. We're not allowed to have a fraction underneath or inside of another fraction. So we need to actually get rid of this half. So looking at what we've got here then, we've got 60 divided by 1/2. Okay, so if we do 60 divided by 1/2, that's going to be 120. A half goes into 1 twice, it goes into 60 120 times. So h is equal to 120 over the square root of t. And there we go, we're not breaking any rules there. We have not got a fraction inside our fraction. So that's perfect, there's our final answer. And we have a formula for h in terms of t. H is equal to 120 over root t. There we go, there's our next one. Let's have a look at our fourth question. Okay, so on to our fourth question. We've got a slightly different type of question here. Now it says y is inversely proportional to x cubed. Y is 44 when x is equal to a. Show that y equals 5.5 when x equals 2a. So It's got a slightly different type of question here, but we'll have a look at how to tackle this one. Now we're going to treat it in exactly the same way as we treated question 1 and 2, except we've got a value of x here, which is a letter, and that letter is a. So let's just follow it in exactly the same way, but putting this letter in instead of a number. So let's see what we get. Now it's inverse proportion, so y is equal to k over x cubed. And again, we're just going to put these two values in. So y equals 44 and x equals a. So we've got y is 44, so 44 is equal to k over x cubed. X is a, so that's going to be a cubed. There we go, so we just need to rearrange this. So multiply both sides by this piece on the bottom here, which in this terms is a cubed, sorry. So times that by a cubed, and we get 44 a cubed is equal to k. And there we go, now we can plug that into our formula. So putting that in place of k there, we would have y equals, and k is now 44a cubed, so 44a cubed all over x cubed. There we go, so all over x cubed. Right, so there is our formula. Now, what do we need to do next? We need to actually show that y is 5.5 when x is equal to 2a. So let's actually go about subbing these pieces in. Now it says show that y equals 5.5 when x is equal to 2a. So we don't need to actually sub 5.5 in place of y, we're just going to show that y is going to equal 5.5. So as long as it equals 5.5 at the end and we get a match, we know we've done this correctly. So let's just go about subbing in this 2a into our formula and seeing what we get. So y is going to equal 44a cubed divided by this 2a, which we're going to cube. So we'll stick the 2a in a bracket just to make sure that we cube it correctly. And then let's go about expanding that little cube there and simplifying this down. So on the top, we've got 44a cubed. There we go. And if we do 2a cubed, that's 2 cubed, which is 8, and then a cubed. There we go, so we're almost done. Now having a look on the top and the bottom there, we have an a cubed on the top and the bottom, so that can cancel each other out. And we'll just be left with 44 over 8. Let's have a look. So we've got 44 over 8. There we go. And again, we can simplify that down. So again, maybe we could divide the top and bottom by 4. So that would be 11 over 2. And 11 over 2 is equal to 5.5 or 5.5. Right, so one little thing that we should show is just how we've simplified that fraction. So that fraction there, we divided the top and bottom by 4 in order to get it towards the 11 over 2, and then we were able to write that as the decimal 5.5. So there we go, we've got 5.5 at the end, so we have shown that y is going to equal 5.5, so we have completed that question there as our answer matches what was asked for in the question. So there we go, there was question 4 completed, and let's have a look at our final question here on our direct and inverse proportion. Okay, so for our final question, and again this is very similar to the one that we looked at in question 3. We've got some inverse proportion, some direct proportion, and we're going to find a formula for y in terms of x, and again give it in its simplest form. So we're going to treat this in a very similar way to we did in that third question. We're going to deal with this one here, where we've got y is inversely proportional to d squared, and then we're going to deal with this one here, where we've got d is directly proportional to x squared. So treating it in the same way, let's create a formula for this first one. So y is equal to, and it's inverse proportion, so k over d squared. And then again, we can sub these numbers in. We've got d is 10 when y is 4. So we've got 4, which is y, is equal to k over d squared. And again, the working out to the side, we've got 10 squared, which equals 100. So k over 100. And again, let's rearrange that, so times both sides by 100, so we've got our value for k, and we get k is equal to 400. And again we can write our formula for that, so let's bring that down here. Let's write y is equal to 400 divided by d squared. Right, there we go, there's our first one done. Let's move on to our second statement here. So d is directly proportional to x squared. So there we go, let's write our formula for that. So d equals k x squared. There we are. And let's plug in those values. So x is 2 and d is 24. So we have 24 equals k times, if I can write that in, times 2 squared, and again let's do the working out down here, 2 squared equals 4, so k times 4, or again let's rewrite that as 4k, so let's get rid of that and write 4k instead. There we go. Okay, so to rearrange that, we're going to divide both sides by 4, so divide by 4, and we get k equals, and we get a value of 6 there. So we go k equals 6, and again we can rewrite our formula there, but having k as 6. So if we write that down here again, we have got d is equal to 6x squared, and there we go, there's our two formulas written. Now again, if we just read this question carefully, it says find a formula for y in terms of x. So we have this formula on the left here that says y is equal to 400 over d squared. Now that's a formula for y in terms of d. So we need to replace this d here. And we've got this formula over here that says d is equal to 6x squared. So what we're going to do is we're going to put that 6x squared in place of d. And if we do that, let's see what we get. So we'll get y is equal to 400 over d squared. Now d is 6x squared, so I'm going to put that in a bracket. So 6x squared, and that is going to be squared. Okay, so we're nearly done. Right, we just need to square what's on the bottom there. So y is equal to, we've got 400 on the top, and if we square what's on the bottom, 6 squared is 36, and x squared squared is x to the power of 4. Remembering that you just times powers when they're in brackets like that. So there we go, 400 over 36, x to the power of 4. Now again, it does say give it in its simplest form. We're almost done, but the top and bottom here both divide. Now they both divide by, and you might not spot the biggest number straight away, but they both divide by 4. So on the top there, 400 divided by 4 is 100, and on the bottom there, 36 divided by 4 is 9, so 9x to the power of 4. And then that is in its simplest form, 109. Both don't divide by anything similar, so y is equal to 100 over 9x to the power of 4. And to finish this off really, I should get rid of that little step of working out in the middle, so I can write my final answer as y is equal to 100 divided by 9x to the power of 4. And there is our final answer, so let's just highlight that one there. And there we go, there is a formula for y in terms of x. We've got y is equal to 100 divided by 9x to the power of 4, and there is our final answer. So there we go, there are 5 difficult versions of direct and inverse proportion, all sort of different difficulty levels and different skills involved in each question. But hopefully you found that useful and helpful. As I said at the start, don't forget to check out the full playlist here on direct and inverse proportion if any of these were sort of a little bit beyond you and you need a little bit more practice. But there we go, don't forget to share these, don't forget to like the video, and I'll see you for the next one.